Hello friends, welcome back to my channel FoS Physics. In today's session, we will learn about laser, laser principle and about components of laser. So let's start. First we will see what is laser. Laser stands for light amplification by stimulated emission of radiation, and let's see the definition of laser. A device that produces a monochromatic, unidirectional and highly coherent beam of light by stimulated emission is called laser. Let us see some history of the laser. Laser is the outgrowth of maser, which is a device that amplifies microwaves. Maser stands for microwave amplification by stimulated emission of radiation. First successful maser was an ammonia maser that was built by Jordan Geiger and Charles Towns in 1954. And due to this invention, Charles Towns and his fellow get a Nobel Prize in Physics in 1964. In 1958, Arthur Swallow of Bell Laboratory and Charles Towns presented that the Maser principle can be extended into the visible region also. And due to this presentation, or with the help of this presentation, in 1960, T.H. Maimon built the first laser using ruby rod as the active medium, and laser was called this laser is called ruby laser. And helium neon laser was developed by Ali Jawan and his associates in 1961, and since then lasers are used in various fields. Now let us compare the laser beam with incandescent light. This is the bulb which emits incandescent light, and this is the laser which emit laser beam. And if we compare these two uh, light source, then we get following difference between these two. And incandescent light, there is many wavelengths, and incandescent light is multidirectional and incoherent. But when we see laser beam, then we find that it is monochromatic, unidirectional, and coherent. This is the major difference between incandescent and laser light. Now let us see basic concepts of a laser, or it is also called laser principle. And this laser principle was known by using following topics like absorption, spontaneous emission, stimulated emission, and population inversion. Now let us see about absorption. Suppose there is a atomic system in which there is a two energy levels of energy E1 and E2, in which suppose there is a N1 and N2 is the number of atom in the energy level uh, E1 and energy levels of energy E2 respectively. This energy level of even energy is also called lower energy state, and this energy levels of energy E2 is called higher energy state or excited state. Suppose this is a atom, and if we incident uh, if photon is incident in this atomic system, then this ground state atom absorb this photon and jump to higher state such as, and this process is known as absorption. Hence the absorption can be defined as the process of raising an atom from ground state to excited state by absorbing an incident photon is called the absorption. The photon of energy h nu is absorbed by an atom only if the energy of incident photon will be equal to E2 minus E1. Now let us see about spontaneous emission. As we know that after absorption, the atom is in excited state, and in this state, the lifetime of atom is in the order of 10 to the power of minus 8 second. After this time, the atoms come down to ground state by releasing a photon of energy h nu, and this process is known as spontaneous emission. Let us see the definition of spontaneous emission. The process of releasing energy in the form of photon due to spontaneously decay of atom from higher energy state to lower energy state is called spontaneous emission. It is a completely random process. Now let us see about stimulated emission. When atom is in excited state, if we want to take this excited atom in ground state before its lifetime, then if we incident photon, and if the incident photon interacts or trigger this excited atom to come down to ground state, then the atom of excited state come down to ground state, and in this process two photon of same energy h nu releases, and this process is called stimulated emission. Hence, let us see the definition of stimulated emission. Hence, when the atom is in the excited state, then an incident photon is triggered the excited atom to fall down to lower energy state by releasing of another photon is called the stimulated emission. And this is the definition of stimulated emission. And stimulated photons have some unique properties. That means in stimulated emission, the photons emitted have some properties. Let us see the properties of stimulated photons. This stimulated photons ha, is in same phase with the incident photon, and incident photons and stimulated photons have same wavelength as the incident photon, and this stimulated photons travel in same direction as the incident photon. Now let us see about population inversion. Let us see, this is the two energy levels. Initially, most of the atom is in the lower energy state, and a little number of atom is in higher energy state. Here, that means we can say that here N1 is much greater than N2. If in any by using any process, if we change the number of atom in between higher energy state to lower energy state, that means if in there is a large number of atom is in higher energy state, and little number is in the ground state, then this condition is called the situation of population inversion. Hence, now here we can see that N1 is much less than N2, and the situation in which more number of atoms or molecules are in a higher excited state as compared to lower state is called population inversion. Population inversion can be achieved by optical pumping, in which the atoms in the ground state are excited to higher states by absorption of photon. Let us see about pumping. The process of raising a particle from lower energy state to higher energy state is called pumping, and this process pumping can be obtained by many ways like electrical pumping, optical pumping, X-ray pumping, and chemical pumping. Now let us see the components of laser. There is a One component of laser is active medium, another component is energy source, and another component is optical resonator. Actually, there is a many components of laser, but these three is the main components of all lasers. Let us see the arrangement of components of laser. That means how components of laser is arranged. And the active medium and the energy source, and it is also called pumping pump, and in two sides of active medium there is a two mirror. This one is one mirror and this one is another mirror, in which this mirror is work as a 100% reflective mirror, and this mirror is partially reflective mirror, and the laser beam is emitted through partially reflective mirror, and this is the arrangements of components of laser. Let us see about the components of laser in which let us see about active medium. Active medium, according to type of laser, there is a many types of material is used as a active medium of laser. In solid state laser, Nd:YAG, ruby, and semiconductor diode is used as a active medium. But in gas laser, argon, krypton, carbon dioxide, argon fluoride, excimer, helium neon is used as a active medium, and in liquid laser dimaterial is used as a active medium. Now let us see the second components about the second components of laser, energy source. In solid state laser, incoherent light source is used as energy source, and in gas laser, electrical discharge between electrode is used as a energy source, and in dye laser, other lasers is used as a energy source. And last component is optical resonator. A system of two mirrors placed in front of each other, one being fully and other partially silvered, is called optical resonator. It amplifies light by promoting stimulated emission and suppressing spontaneous emission. And this is the actual arrangement of components of laser. This is the active medium and this is the pumping source, or it is also called energy source, and these two mirrors makes optical resonator. Here this is the partially reflective mirror and this one is the 100% reflective mirror. Okay friends, if you have any doubt, then you can ask through comment box. Thank you for watching. If you have not subscribed till now, then please subscribe to my channel to get the notification of every new video. Okay, thank you.